Hey, ladies and gentlemen, Mr. Massey here, back with you. We're going to talk about more math. Yeah, I know you're excited about it. Woo! Well, today, what's on the agenda is graphing some quadratic functions that are in vertex form. They're slightly different than when graphing them in standard form, so I want to show you the difference. So first things first, the book's going to talk about this parent function a lot. Now the parent function is essentially this guy here. It's just going to be your x squared, this guy. It's going to be your parent function. Now your parent function is simply x squared. It's going to be your basis, your foundation moving forward, so you're going to need to get familiar with this. Now what the parent function looks like when graphed is simply this. If I take a handful of numbers, a couple of negatives, a couple of positives, and a 0, and I plug them in to my function, just my x squared, I'm going to spit out some y values, right? Spit out some of these guys. My graph's going to take the shape of a parabola. I know you've heard this before. So a parabola looks something like this. If I take these numbers, if I take -2 and plug it in for x, -2 squared spits out a 4, yada, yada, yada. Here, if I graph this thing, it should look something like this. It should be a little parabola with the vertex at the origin. What's my vertex going to be? 0, 0. Perfect. I think I heard someone say that. 0, 0. That's my vertex, all right? But now what you're going to have things like this in vertex form, all right? They call it vertex form because the vertex is easily identifiable. Whatever your h and k are, they become your vertex. Whatever your h and k are, all right? Now this negative sign right here is built into your template. So if this says like x minus 3, your vertex is going to be a positive 3. So whatever this sign is in your parentheses, it's going to be the opposite here for the x value of your vertex. All right? So what I have for you is I have an example problem, this guy in pink that I want to graph and compare to the graph of my parent function. I want to show you how we can transform my parent function by adding certain numbers into my vertex form templates, all right? Now these numbers are going to transform or shift my graph. So I want you to think that all parabolas start out right here. They all look like this when they're born, right? And if we add numbers, we can change how they look. We can shift them up, we can shift them down, we can shift them left and right, we can make them skinnier, fatter. We can manipulate this parent function, right? So check it out. I'm going to mark this thing up. So this guy right here, right, this guy in purple, this little 3, my A value, this guy here tells me 2 things. Just by looking at this guy, I can see if this thing opens up or down and if it's skinny or fat. All right? So I'm going to tell you a little secret. If this guy's positive, he opens up. So in this case, is that a positive or negative? You can say it. It's a positive. So does it open up or down? This guy opens up, right? If I ask you if it's skinny or fat, this guy's going to determine that. Fractions and all fractions are fat, positive or negative. It's a fraction, he's a fat parabola. Numbers are skinny. If it's a positive or negative, like a -3, -4, -5, that's skinny, but it opens down. If it's +3, +4, +5, that's skinny, but it opens up. So this guy's a regular number, so it's going to be a skinny little fella. He's positive, so he opens up. All right? Now here, these guys right here in orange, this thing right here, that tells me if it opens, or I'm sorry, if it gets shifted left or right. So whatever's in the parentheses, if you change the sign, that's the shift. So this is my horizontal shift in my parentheses. Since that's a -4, it gets shifted to the right 4 units. Whatever that sign is, it gets shifted the opposite direction. So if that's a -4, it gets bumped to the right 4 units. All right? Now, if it opens up or down, we're going to make this guy the green. My k over here, whatever my k value, this free floater, this guy hanging around outside the parentheses, he's going to determine, running out of room, my vertical shift. If this guy gets bumped up or down. Now he's going to be straightforward, straight up, whatever it is it is. If that's a -1, he's going to be bumped down 1 unit. Down 1 unit. All right? So here they call this the vertex form because the vertex is easily identifiable. No math needed, we're just eyeballing this thing. All right? So again, there's been no math here. It's just recognizing and observing patterns and reacting to them. All right? So my vertex is this. If that goes right 4 units, actually, let me call a curveball. I like to graph this thing first and foremost. All right? So here we go. Let's get my magic marker going. If this was my parent function, this was my original vertex, right? And we shifted this guy right 4 units. I'm going to go 1, 2, 3, 4. That's going to be my new shift. I shifted him right 4 units. I also shifted this guy down 1 unit. So if I shifted him 4 to the right and down 1, this is going to be my new vertex right there. All right, at 4, -1. 1, 2, 3, 4, 1. I shifted them right 4 units and down 1. So I have my parent function. I manipulated this thing. I shifted them right and shifted them down. So here, I'm going to change colors. I'm going to make this thing, an orange graph. All right? So here, I've made this thing skinny. Right? I've made this thing skinnier. I've changed the vertex on this guy. So now my vertex is simply 4, -1. Now, if I'm going to graph this thing, I can just make it a little bit skinnier. Scoop, scoop, scoop. This guy's skinnier. He opens up. I've shifted my parent function. I've made it more narrow. And I went 4 over and down 1. So if I ask you the transformation of this thing, this guy opens up and skinny. He went right 4 and down 1. Call it a day. All right? So if we go over here, I want to do the same thing, but I want to do this one a little bit more quickly, a little more rapid fire on this one. All right? So I'm going to ask you a few questions, and I want some answers. All right? Just by looking at this thing, all right, does it open up or down? Down. Why do you say that? Because it's negative. Yeah. Is this guy a skinny graph or a fat graph? It's a fat graph. Why do you say that? Because it's a fraction. Yeah. All right. Does it go left or right? What's in parentheses? That's a +3. All right. So does it get shifted left or to the right? It gets shifted left. How many units? 3. Awesome. Okay. How about up or down? Does this thing get shifted up or down? Well, what's outside the parentheses over here? That's a +4. You know it. So it gets shifted up 4 units. All right. So if my parent function normally has an origin at 0, 0, and I shifted this guy left 3, 1, 2, 3, and up 4, 1, 2, 3, 4, here's my new vertex, right? So what's my new vertex? I got a -3, +4. That's my new vertex. Opposite of that sign, same of that sign. Cool. This thing opens down and it's fat, so I'll take something like that if you're just doing a rough draft vertex drawing, a rough draft parabola sketch, all right? How about this guy, example number 3, in blue? Where's my magic blue marker? Does this guy open up or down? Down! Yeah, why do you say that? Because my A is negative. So this guy opens down. Is it skinny or fat? That's a skinny little sucker because it's not a fraction. That's a skinny guy because it's not a fraction. Did it get horizontally shifted? Yeah. Left or right? Right. How many units? 2. Yeah, so whatever this is, it's the opposite sign. So here I go 2 units to the right. Excellent. This guy get any vertical shifts? Yeah. How many? 3. Up or down? Up. So here we got up 3 units. This 3 after the parentheses. Positive goes up. All right? So if all my parent functions start at 0, 0, right? Looks like I went 2 units to the right and up 3 units. Bam. This guy opens down and he's skinny. Opens down and skinny. My vertex is going to be, what's that? 2, 3. Opposite of him, same sign as him. All right? So a quick recap. This guy in the front tells you two things. If he opens up or down, skinny or fat. That's your horizontal shift. Whatever that sign is, he moves in the opposite direction. That's your vertical shift. He is what he is. That's all, folks. Graphing quadratic functions in Vertex form.